So I have redrawn all the spaces here so that we can keep the chart cleaner and focus on the transformation. To transform the object space to the world space, we take help of model matrix. We multiply the object space with the model matrix and we get the world space coordinates. And then we have to transform world space to the view space. And in order to do that, we multiply world space with the view matrix. And then from the view, we have to transform to the projection space. And to transform the matrix from view space to the projection space, we multiply the matrix with the projection matrix. And then the hardware clips the object and transforms it into clip space matrix, but we will skip that step because we don't have the control of that step in our shader. For us, what is visible is from projection space to the normalized device coordinates. To transform projection matrix to the normalized device coordinate, we do the homogeneous or the perspective divide. And what is homogeneous and perspective divide? To take that example, let's map the values again of this vertex. So from the object space, it's at 0, 1, 0. In the world space, it's at 0, 11, 0. In the view space, it will be at 0, 1, negative 10. And in the projection space, 0, 1.7, 8.2, and 10. So here, 10 is the W value. When we have to transform the projection space position to the normalized device coordinate position, we divide the x, y, and z value by the w value. And we get the normalized device coordinates. And this is the one of the most important steps where we use the w value. And once we divide x, y, z value, we get the values within the range of negative 1 to 1. I have created a scene in Unity in which I will demonstrate this with an example. So the normalized device coordinates are in the range of negative 1 and 1. And the center of the normalized device coordinate is 0, 0. The top left corner is negative 1, 1. The bottom right corner is 1, negative 1. And the top right is 1, 1. And the bottom left is negative 1, negative 1. And now we will have to transform normalized device coordinates into texture space coordinates. And we know that the texture space coordinates are in the range of 0 to 1. And how we will transform normalized device coordinate to the texture space coordinate? To take a look at that, we will look into a graph or a diagram. So if we have a scale which has 0 at the center, negative 1 here, and negative 2, 1, and 2. And we know that the range of normalized device coordinate is from negative 1 to 1. So this is NDC. If we add 1 to NDC, we will shift this range from 0 to 2 because we have added 1 to it. Previously, the NDC was in the range of negative 1 and 1. Now this will be in the range of negative 1 plus 1, 1 plus 1, which becomes 0, 2. And then if we divide it by half, which is multiplying NDC plus 1 divided by 2, which means 0 divided by 2 and 2 divided by 2, this gives us the range of 0, 1, and that is what we are looking for. But let's take a look at this calculation in detail. So here we will take a look at the calculation of transforming normalized device coordinates to the texture space coordinates. And this will be the basis of our shadow mapping. This is the exact calculation that we will be using in our shadow mapping. We will understand later why we will be using this calculation. but pay close attention because we will be using the complete formula or the function in our shadow mapping shader. So our objective is to transform a range of -1, 1 to 0, 1. So we take NDC, which is in the range of -1, 1 and 0. In the second step, we add 1 to it. So this range becomes from 0 to 2. And then we divide it by 2 and the range becomes from 0 to 1. Now let's backtrace the value of normalized device coordinates. What is the value of normalized device coordinate? The x of normalized device coordinate is the projection space coordinate x divided by projection space w, which we can say that x divided by w. And what we are looking for in the texture space is the u and the v value, or s, t value, which is in the range of 0, 1. And the x will correspond to the u and y will correspond to the v. So let's first find out the texture space u value, because u corresponds to x. So NDC for u becomes x divided by w, which is the homogeneous or perspective divide. And then in the second step, we added 1 to it so that the range can become from 0 to 2. And then we divided it by 2, which means multiplied by 1 divided by 2. Let's simplify this equation. If you remember fraction addition, if we have to add the fractions, we find a common denominator, and because there is no w here, and in order to find this common denominator, you multiply the numerator with w as well. So this equation becomes x plus w divided by w multiply by 1 divided